Hello, now let us look at this question 19. Now in this question we are solving trigonometric equations, but now we are going to see how we can use the R formula and the T formula to solve any trigonometric equation given. So let us see, we should always recall that when T is equal to tan theta by 2, then sine theta is equal to 2t over 1 plus t squared, and cos theta will be given by 1 minus t squared over 1 plus t squared. You need to know this. Now when we have an equation where I said it's t, when it is tan theta by 2, then solve the equation, then you need to use these substitutions. So from the given equation we have 3 cos theta minus 5 sine theta equal to -1. So I'll just put 3 where there is cos. I put 1 minus t squared over 1 plus t squared, then minus 5. Sine is 2t over 1 plus t squared equal to -1. Now here what I'm going to do is multiply with 1 plus t squared throughout so that I get rid of the denominator. So this will be 3 minus 3t squared minus 10t equal to -1, then minus t squared. If we multiply with 1 plus t squared throughout, then we shall be having our t. Let me say this is -3t squared plus t squared, then minus 10t plus 3. This 3 here, I bring 1 this side, then plus 1 equal to 0. I have brought terms on the right to the left part. So now let us see. This is going to be -2t squared minus 10t plus 4 equal to 0. If I multiply with a negative, let me divide with -2. This will be t squared plus 5t, then minus 2 equal to 0. So now we need to find t. T will be equal to -b, negative. Now our a is going to be 1, our b is 5, and ours is -2. So we get -5 plus or minus the root of 25, which is the b squared, minus 4 times a -2, which is the c, then divided by 2 times 1. So our t will be equal to -5 plus or minus the square root of 25 plus 8, that is 33, divided by 2. So the two values of t shall have -5 plus root 33 over 2, and -5 minus root 33 over 2. So the two values of t will be, so the two values of t, we have 0.37 and -5.37. But don't forget t is theta by 2, and we are looking for theta. Okay, so it implies that tan theta by 2 is going to be 0.37 and theta by 2 will be equal to the tan inverse of 0.37. So our theta by 2 will be equal to, we are going to find out. Also, tan theta by 2 will be equal to negative 5.37. So our theta by 2 will be equal to the tan inverse of negative 5.37. So let us find out. So from here, when we take tan inverse of 0.37, we get 20.3. 20.3 degrees. But now we need to find where tan is positive. Tan is positive in the third quadrant, so 180 plus this. But that will be out of the range because we are going to multiply by 2. And when you multiply 180 by 2, you will be getting an angle which is outside this. So that stops there. Now let us see. Okay, this is what I mean. When you are looking for the region where tan is positive, we do have this angle which is 20, and this angle it is 20.3. Now the next angle will be here, so we shall get 180 plus 20, which is 160.3. And when you multiply with the 2, it will be bigger than 360. So we leave the next angle. So now let us see theta by 2, tan inverse of negative 5.37 the tan inverse of negative 5.37 is a very small angle. So, we use the tan, it should be tan inverse. So let us find the tan inverse instead. So tan inverse of negative 5.37 negative 5.37, we get negative 79. So let us see where tan is in the positive is negative. We have these quadrants. So this is negative 79.5. So we also have here 79.5. So but we are in the positive side, 0 to 360. We don't need to move in the clockwise. So we need to get this angle also. Any other angle will be outside the range because we shall be multiplying it with the 2. So this angle here is 180 minus 79.5 degrees. So that gives us 105 100.5 degrees. So we multiply it by 2 to get our theta. So theta here will get 40.6 degrees. Then here we shall get 201 degrees. So that is the solution for the first part, and that is how we use the t substitution. We are going to see even in part B